everyone. In our earlier video, we have seen what are the metal carbonyl clusters, how it is forming, and we have seen the structures of low nuclear carbonyl clusters, right? Now we're going to see high nuclear carbonyl clusters. So the M5 type, so it is nickel 5 CO12 nickel carbonyl cluster. So five metal atoms are linked with each other like in trigonal bipyramidal structure. So these are three equatorial metal atoms and these two are axial metal atoms, right? So equatorial metal atoms, each metal atom is linked with one terminal, one bridging. Whereas the axial metal atoms are linked with three terminals each. And if you see the total electron count for this M5 type carbonyl cluster, 5 nickel atoms are there, right? So 5 nickels, 5 into valency of the nickel is 3d8 4s2, right? So 10 will be 50 and 12 carbonyls ligands are there. Therefore 12 CO, each carbonyl is donating 2 electrons, 12 into 2, that is 24 electrons, so that the total electron count will be 74 electrons. If we go for M6 type of metal clusters, 6 metal atoms are attached in octahedral manner, octahedral structure it is, and each metal atom is linked with 2 terminal carbonyls like this, right? Each metal atom is linked with 2 terminals and 4 carbonyls, 4 bridging carbonyls will be arranged on alternate triangular face of this polyhedron, alternate triangular face of octahedral structure. If you see the total electron count, 6 rhodium atoms are there, 6 into valency of the rhodium 9 and 54 electrons. 16 carbonyls are there, 16 carbonyls, each carbonyl is donating 2 electrons, therefore 32. So total electron count is 86. If you see M7 type of clusters, so 6 atoms will be arranged in octahedral manner and the extra one metal atom will be arranged in over that one of the triangular face of the octahedron. And each metal atom is linked with 3 terminal carbonyls each. So this structure can be called as the extra metal atom is placed upon over a triangular face and it is looking as a cap. Therefore, it is called as monocapped octahedron. If you see the total electron count, 7 osmium atoms are there. 7 into valency of the osmium is 8, 56. And 21 carbonyls, 21 into 2 electrons, 42. So total electron count is 98. If we go for M8, so 6 metal atoms are arranged in octahedral manner and extra 2 metal atoms are placed over the triangular faces of this polyhedron. So 2 caps are here. Therefore, the structure can be called as bicapped octahedron. And in this structure, the 6 octahedral arranged metal atoms are linked with 3 terminal carbonyls each and the bridging metal atoms will be linked with 2 terminals each. So therefore CO22. And if you see the total electron count, 8 osmium atoms and 8 into valency of the osmium is 8, 64. 22 carbonyls, 22, each carbonyl is donating 2 electrons, 44. And the charge of the complex is plus minus 2. Therefore, we have to add the 2 electrons, 2 electrons. So the total electron count is 110 electrons. And if you see the M10 type, M10, osmium 10 C CO24 minus 2. The structure of the metal carbonyl cluster is 6 metal atoms are arranged in octahedral manner and 3 metal atoms are arranged over the triangular face and one more metal atom is arranged in this triangular face. Okay. So, and this big dot, the black dot is can called as carbon. It represents the carbon. If you see and the structure can be called as tetracapped octahedron. So if you see the total electron count, 10 osmiums, 10 into valency of the osmium is 8, 24 carbonyls, 24 into 2 electrons each, 48, right? 1 carbon, 1 into valency of the carbon should be add. So 4, and charge of the cluster is -2. So we have to add plus 2 electrons, so 2. So the total electron count is 134.